Hello everyone, this is going to be a short presentation on my poster which I'm presenting as part of Discover 2024. My work is basically focusing on understanding the controls behind uh, the precipitation in Montana in both the eastern and western part. The eastern part of Montana is very dominated by the Great Plains, and the western part is very topographically high, dominated by the Rockies. So we expect to see different precipitation patterns which will be reflected on the precipitation and river water stable isotopes, namely the hydrogen and oxygen isotopes, the ones which are present in the meteoric water or the precipitation waters as well. Uh, that's why we are looking at Montana. We had two sampling seasons in Montana. One is in 2017 and one is in 2021, where we collected river water across different points in the western as well as the eastern parts. And we analyzed the del D and the del 18 values. This is essentially the heavier to lighter isotope ratio of the hydrogen and the oxygen values respectively. These generally have negative values. However, the negative values can be more or less depending on various different factors that we're going to be outlined in the later parts. However, this is a general trend that is observed that the del D and del 18 values is increasing towards the east. The second thing we wanted to understand was how the del 18 and the del D values are varying with elevation. Elevation has seemed to be a major contributing factor of these values all across different parts of the world. We wanted to see if it's the same case here. In general, we should get a negative correlation where higher elevation means lower del 18 and del D values. So we did that correlation over here. However, what we just did see is mostly, in most cases, very low correlation values. So there is little to no correlation at all. The only place where there is consistently good correlation for both the del D and del 18 values is the Western Transect in 2017. That the same cannot be said for the other transects, even though the Eastern Transect in 2021 had a good del 18 correlation, the del D correlation was very different. This suggests that there should be other factors at play, which is driving the control or major control away from elevation towards other factors towards these values. So to understand that, the first thing we did was trying to see where the moisture was coming from into the region. We collected some rainfall data from some elevation, or rather precipitation stations near the study areas, and we did modeling analysis to see where the moisture was coming from. Our modeling showed that there are dominantly two sources of moisture. One is the Western Pacific, and the other moisture is the moisture that is being re-evaporated by on the continental interior and reprecipitated over here, uh, which would have varying amounts, with more amount of continental moisture coming from the east. Uh, so these two sources would introduce a significant amount of variance in the del D and del 18 values as well. I suspect that the amount of continental moisture is playing a big part in that. The second thing is going to be to assess the effect of evaporation. We looked at relative humidity across the two sampling seasons and across Montana to see if the higher values had higher relative humidity or the lower values have lower relative humidity. It is essentially an indicator of evaporation. Higher evaporation would lead to higher del D values. And we see the same thing. We observe that the higher del D values are in regions which have higher or rather lower RH values, which are indicative of evaporation right over here in both the sampling seasons. So in the eastern part, the evaporation is largely the controlling factor between the del D and the del 18 values. Even though the river water is close to the precipitation water values, we suspect that because of the absence of correlation with elevation, the river water is dominated by the snow melt, which is driving all of the values to more or less an average value that is also being observed over here. So all in all, there are three main factors affecting the del and del values. Those are the different sources in the different parts, higher evaporation towards the east, and the snow melt dominating the rivers in southeastern Montana, uh, which is bringing all the del D values and del 18 values to average values all across different elevations. That's going to be a short gist of my project. Thank you for listening, and I hope to see you all there in the presentation in person. Thank you.